So we're still looking at combining forces and splitting them, and we're going to do an example from the miscellaneous chapter 9. First of all, we're going to have each of two forces is x newtons, and between them, when they're together, they have a resultant force of 12 newtons. The magnitude of one of these forces is increased by 70%, and we have a new resultant of 21 newtons. And we're asked to find x, the size of the original forces, and the angle between the two forces. Okay, so let's think. In both of these scenarios, I have two forces and a resultant. Two forces and a resultant. That means I can put together my triangle of forces. Okay, the first one will look like this. Two forces of equal magnitude, different directions note, but equal magnitude to give me a resultant of 12 newtons. In this diagram here, one of the forces has been increased by 70%. So what I have here is 1.7x and then the original x as well, giving the resultant of 21 newtons. Now, the important thing to think about in these is although this one has grown, is now 1.7 times as big, the angles between these two original forces is going to stay constant. So I'm going to label this force in the triangle theta. And we'll talk more about that force later. Right. Two triangles, two sides and an angle between them and a resultant. For both of these triangles, I can use my cosine rule. I can't use sine because I don't have any pairs, so I need to use my cosine rule. So starting with this side, 12 squared is equal to x squared plus x squared minus 2 times x cos theta, which is what I've got here. And then this triangle here, I've got 21 squared is this side squared plus this side squared minus 2 times this side cos theta again. So now I've got two, albeit they're quite large, I've got two equations and two unknowns. So I'm going to use this one here to find something that I can substitute into this equation here. So I'll rearrange it. Taking each step, pulling my like terms together, okay? And then what I'm looking for is, I'm looking for what is cos theta. Now it's more complicated to arrange it to get x squared equal to, but you could do that as well, okay? I've popped this on this side and moved the 144 to here, divided by 2, and then I'm left with cos theta is x squared minus 72 over x squared. And I'm going to substitute this. I'm going to substitute it into the equation over here, which I have calculated the numerical values of. And then this cos theta I'm going to replace with this part here. So moving on, here's my substitution. You'll see I've got the same equation, but instead of cos theta, I've got my replacement. I can cancel my x squareds, and it gives me this lovely equation here. Now I have an equation just in x. So rearranging like terms together, I get a number for x squared, which I can take the root of, and it tells me my original forces were magnitude 20 newtons. Now I've got to think about the angle. Okay, so we go back and we say, let's think about this angle theta. I now know this side, I know this side, I know this side, so I can replace it into either this equation here